From self-driving cars to smart factories, modern systems don't just operate, they respond. But how do they know what to do? The answer lies in sensors and actuators, the sensors and muscles of industrial automation and smart control systems. In this video, we'll break down how these components work, not just in gadgets, but in large-scale systems like power plants, water treatment, facilities, and factories. What are sensors? Let's start with sensors. In the world of automation and control systems, sensors are the eyes, ears, and skin of machines. Just like our sensors detect and interpret the world around us, sensors gather information from the physical environment and convert it into signals that machines can understand. But unlike us, machines can't see or feel. They rely entirely on sensors to give them input. What do sensors detect? Sensors can monitor a wide variety of physical and chemical properties, such as temperature, using thermocouples, RTDs, or thermistors, pressure, in pipelines, hydraulic systems, and tanks. Light, for brightness control or object detection. Proximity, to check if a machine part is in position. Motion or speed, to track movement or rotations. Level, to measure the contents in a tank or hopper. Flow, how fast a fluid or gas is moving. Vibration, often used for predictive maintenance. How do sensors work in automation? Once a sensor detects a change in its environment, say, a temperature drop, it translates this change into an electrical signal. That signal is then sent to a controller, typically a PLC, programmable logic controller, or a DCS, distributed control system. The controller then uses this data to make a decision. For example, if the temperature gets too low, the PLC might activate an actuator to turn on a heater. Sensors equals smart inputs. Think of sensors as the smart input side of automation. Without sensors, a control system would be asterisk blind and deaf star. It wouldn't know what's happening in a process, whether a tank is full, whether a machine part is in place, or whether a system is overheating. In essence, sensors bring real-world awareness into digital systems, forming the critical first step of any automation loop. Real-world examples. In a bottling plant, optical sensors detect whether bottles are correctly aligned before filling. In a power plant, pressure sensors continuously monitor steam lines for safety. In water treatment, level sensors ensure tanks don't overflow or run dry. In smart buildings, ambient light sensors adjust indoor lighting automatically to save energy. So, whether it's a small smart device or a massive industrial operation, sensors are where all automated decision-making. Industrial sensor types. In industrial settings, sensors are more rugged and precise. Common types include pressure sensors, used in oil pipelines and HVAC systems. Proximity sensors, to detect if a part is in place on an assembly line. Flow sensors, to measure water or chemical flow in processing plants. Level sensors, detect fluid levels in tanks. Vibration sensors, for monitoring rotating machinery health, predictive maintenance. What are actuators? Once the system senses the environment, it needs to respond. That's where actuators come in. An actuator takes commands from a controller and physically manipulates the system, turning, pushing, pulling, opening, or closing something. Types of industrial actuators. In industrial control systems, actuators are more than just moving parts. They are precision-engineered devices designed to handle high force, repetitive motion, and extreme environments. Let's explore the main types of actuators you'll encounter in industrial automation, what they do, how they work, and where they're used. 1. Electric actuators. Electric actuators use electric motors to create rotary or linear motion. They are clean, relatively quiet, and easy to control using digital signals. These actuators are ideal for robotic arms in manufacturing, CNC, computer numerical control, machinery, automated gates, sliders, and dampers. Small valve positioning where precision is key. One of their biggest advantages is precise positioning and easy integration with PLCs or servo controllers. 2. Pneumatic actuators. Pneumatic actuators operate using compressed air to move pistons, cylinders, or diaphragms. They are fast, lightweight, reliable in repetitive tasks. Pneumatics are perfect for high-speed pick-and-place machines, clamping systems in automated tooling, conveyor diverters and air-powered ejectors because they use air. They are also safer in explosive environments like food processing or chemical plants. 3. Hydraulic actuators when raw power is needed. Hydraulic actuators come into play. They use pressurized fluid, typically oil, to move heavy loads with high force. Hydraulic actuators are commonly used in heavy machinery like presses and cranes, injection molding machines, steel manufacturing and mining equipment. They can generate very high torque and force, making them ideal for harsh, rugged environments, though they require more maintenance due to the fluid systems. 4. Valve actuators. Valve actuators are specialized actuators used to open, close, or modulate valves in industrial processes. They come in electric, pneumatic, and hydraulic forms and are widely used in oil and gas pipelines, water treatment facilities, chemical and pharmaceutical plants. These actuators ensure that liquids, gases, or steam are flowing properly and safely, often controlled remotely via SCADA systems. 5. Solenoids. Solenoids are simple yet powerful electromagnetic actuators that create linear motion when energized. They are typically used for rapid on and off functions, sorting and diverting packages, controlling locks, latches and pop-up pins. Though not as strong as other types, solenoids are perfect for quick binary actions, especially where speed and compact design are more important than raw force. Summary. So to recap: electric actuators, precise and programmable; pneumatic actuators, fast and lightweight; hydraulic actuators, powerful and rugged; valve actuators, specialized flow control; solenoids, ideal for quick, binary motion. Each type plays a unique role in keeping industrial systems moving, controlling and responding to real-time data from sensors inside industrial control systems. Now let's zoom out and see how these parts fit together. In an industrial control system, a sensor sends data to a controller, usually a PLC or DCS, distributed control system. The controller processes logic and commands an actuator to respond. This closed loop runs continuously, often managed by a SCADA, supervisory control and data acquisition system. Example, bottling plant. Imagine a bottling plant. A sensor detects when a bottle is in position. A PLC confirms the timing is right. An actuator drops the cap onto the bottle and screws it on, all in under a second and repeated thousands of times an hour. Real-world industrial application sensors and actuators form the backbone of industrial automation, enabling systems to be faster, safer, and more efficient. Let's look at a few examples. Manufacturing. Assembly lines use proximity sensors, pneumatic actuators, and PLCs to ensure every product is aligned and completed precisely. Energy sector. In power plants and smart grids, sensors monitor voltage, temperature, and flow rates. Actuators adjust turbines, valves, or circuit breakers in real time. Water treatment. Flow sensors and chemical sensors monitor water quality. Actuators add chemicals or divert flow as needed to meet safety standards. Smart infrastructure. Bridges with vibration sensors detect stress. HVAC systems use temperature sensors to optimize energy use. To wrap it up, sensors and actuators don't just live in smartphones and cars. They're fundamental to how industries run entire operations safely and efficiently. From managing massive water systems to assembling microchips, these components help machines sense, decide, and act 24/7. Thanks for watching. If you want more breakdowns of how industrial systems work, hit that like button and subscribe for more tech insights.